So, alright guys, today we'll be talking about the simple pendulum. I just want to do a bit of a calculation on it and then explain certain things concerning the topic. But I can't do that before because I need to explain what this is often discussed under simple harmonic motion. Simple harmonic, for space, let me use this, simple harmonic motion. So, what's simple harmonic motion? I think that's very important. We'll talk about it a bit. You will call it SHM, right? Alright, a body is said to be in simple harmonic motion when it moves to and fro such that its acceleration is directly proportional to its distance from the point of rest, or acceleration is directly proportional, that's A, to the distance, which can be L, can be X, from its point of rest. Of course, there are a lot of equations to talk about that, but I won't dwell much on that. Then, under this concept, you will hear things like frequency. You hear things like period, all right? Frequency, then you have period. These are two. Then you talk about also, that reminds me, amplitude. Now, these three key words you come across in SHM and simple pendulum. Now, what's frequency? I like to make things a little bit practical and more realistic. When you say, let's go back to our English. When you say frequency could be, it could tell of how regular you are to a thing. For example, in common English, if I say the frequency of your visits, or your frequent visits to my house, I'm telling you the regularity of your visits. So the same thing, but a little bit touched in physics. So when you talk about frequency, you're saying the number of oscillation per time. So frequency, F, is simply number of oscillation, and I've said it before, when you hear per time, it's often talking about over time or per second. So it's basically N over T, number of time. All right, so there you have frequency, very simple. The next thing we'll talk about is period. Now, period is basically, it speaks of time. Never forget this. So somebody says my period on earth is 100 years, Methuselah 969, like that. So you're simply saying the years. So basically it's time, but it is time measured with respect to the number of oscillation. So we are going to have time over number of oscillation. Okay, not too stable. Okay, number of oscillation. So that's small t over n. Now, if you look at these two together, you will see that period is the inverse of frequency. That means period t is equal to 1 over f, or f is equal to 1 over t. This is very, very important if we are going to really understand, because we have questions that touch some of these things and you need to have a good understanding of the basics. Now, let's take an example of a question. So let's take another harder one. Let's say something a bit. Now, we are greeted with this question. It says, what is the frequency of a simple pendulum that makes 40 oscillations in 35 seconds? So again, our solution. Now, we already know the number of oscillation from this question. Number of oscillation is equal to 40. All right, our time is equal to 35 seconds. Now, if you recall from here, we see that it says you find the frequency. What's the frequency of a simple that makes, okay, frequency, that's just what they asked for. Now recall, frequency is equal to what do we say? We said is the number of oscillation over time. So, and here, what's our number of oscillation? We already have it as 40. Okay, and what's our time? We have 35 seconds. Okay, so we have our frequency as 40, number of oscillation as 40, time is 35 seconds. If you divide that by that, it's going to give me 1.14 hertz. Okay, but suppose we are asked to find the period t. Period t will be equal to 1 over f. That's 1 over 0.14. Sorry, not 0. We got 1.14 hertz. So if you do that with your math calculator, you should have something close to or exactly 0.875. Or you can come directly and just say t is equal to we said is the time here is 35 seconds over number of oscillations 40, which is 0.875 seconds. Take note of the unit, seconds. Unlike this, the unit is what? Hertz. This is very, very critical. So having touched that, let's go to the meat of the matter today. What I really want us to touch, and that's an understanding of how to work with when you have multiple lengths and multiple periods and all of that. So how do you handle such a... So now let's deal with it. We have two questions here that are connected to Pendulum. So I want us to just look at it and provide solutions. Now, if you recall very well, oftentimes I say that let me use another pink ink. So if I say t, we call that t equals to 2 pi square root L over G. This is a very important question formula when it comes to dealing with pendulum. Please take note of this. Now, if you watch closely, you will see that the period t is having a relationship. Assume all these other ones are constants. There's a relationship between these two to be this, and this is directly proportional, right? So we can say technically view this as t is directly proportional to square root of L. Okay, so because the period is directly proportional to the length of the square root of the length of the pendulum. So can we now say therefore that let's deduce something? We can say that t from our direct relationship formula is equals to k square roots of L, or if you want to better still, we can look at it as, we can say that if t is equal to root L, if we imagine every other one as constant, we can therefore say that t square is directly proportional to L. And so we can, if we extend this further, we have t square is equals to KL. That means that I can say K is equal to t square over L. Now, when you find this expression in sciences, it's just telling you, if you come to this stage, just telling you that you can repeat this variable as many times. So therefore, I can have t1 square over L1 is equal to t2 square over L2, like that. But we're going to stop here because we don't have 3 problems before us, because you just have, when you have 2 periods, often scarcely do you find them give you 3. But if they give you 3, you can still apply the same, get them bit by bit. All right, so let's deal with this quickly. Now I think this should be able to show here. So the first question is a very straightforward question. It says a simple pendulum with a period of 2 seconds has its length doubled. Its new period is what? This is a JAMB question, so let's play with it. Let's play with this question. All right. Okay, so I have this and I'm playing with this. I'm playing with number 1, so I can say since t1 square over L1 is equal to t2 square over L2. Now, from the first question, what do I have as my t1? I have t1 as a simple pendulum with a period of 2 seconds. Okay, so I have t1, I have is 2 seconds. t2, we don't know, has its length doubled. Its new period is, we don't know. Let's see L1, we don't know either. just L. L2, we can call it, has its length doubled, so we can say it's 2L. So if you bring all of these parameters together and substitute into this equation or this, the same, they are both same. So I'm going to have 2 squared over, all right, over, we don't know this, can we call it x, is equal to, okay, the first length is known, sorry, so we can call this L. This T2, we have it, we don't know it, we can call it x squared over L2, we have is what, 2L. So if you work out your maths, here is going to be 4 over L is equal to, here is still x squared over 2L. So I can cross multiply to give me, this would give me x squared is equal to 4 times 2L over L, because you divide both sides. So here this can go away with this. It therefore means that my x squared, or I can choose to use t squared, any of them, it's the same thing. Okay, let me use x since we are using x. So x squared is equal to 8. So it means that x is equal to square root of 8, because when you square crosses over to this side, it becomes a square root. So quickly, I have, if you press this to a calculator, I'm going to have 2.83 seconds. So that is the period when the length is doubled. That is a new period. That is question 1 solved. Now let's look quickly at question 2. Question 2. Let's see what is going on here, because question 2 is actually very simple. So now let's see question 2. What you have here in question 2 is also very simple. But again, we're going to engage our formula principle we've been using before, which is this. All right, we're going to bring about this one. A simple pendulum is period of 4.5 seconds. So you can say T1 is 4.5 seconds. All right, when the length of the pendulum is shortened, that means reduced by, so if the former length was L, L1 is L, so that means L2 is going to be L1 minus 1.2. But they said when the length is shortened by 1.2 meter, the period is now 2.5. So that tells me that T2 is equals to 2.5 seconds. Having said that, we are now asked to calculate the original length, which is this L. Now let's impute it here straight up. T1 is already 4.5, so I have 4.5 all squared over, what's my original length, L1? I have it as, okay, just L. So T2 is 2.5 seconds, or squared. I have it, what's my original, the length here, L minus 1.2. Okay, now can we cross multiply? So if you do that, before then, let's see 4.5 squared. 4, that's 16, that now be 20 point, if you do 4.5 squared, that should give me 20.25. Yes, correct. So I have 20.25 over, what's my length? 20.25 divided by, okay, so this is still remains. This will give me 2.5. That will be 6.25. Yes, it's be L minus 1.2. So can I cross multiply? Can cross multiply. So that means I will have 20.25 L minus, now 1.2 times this 20.25, you're going to going to get something like 14. No, so let me quickly do that in calculator. So it's going to give me 24. Yes, 24.3. So that's equal to, now this 6.25 times L, now be 6.25 L. Now let me collect like terms briefly. This and this, they are like terms, so it can go together. I have 20.25 L minus 6.25 L will be equal to, I take this one outside here, so it becomes, to come out here, it becomes 24.3. so this will give me, subtract this together, it will give me 14 L is equals to 24.3. Now if you divide both sides by L, L is going to give me 24.3 over 14, and that will be equal to, if you do that, we can 1.74, since its length is going to be meters. Now then, one way to check the correctness of this is that this value ought to be more than 1.2. So that means the original length is 1.74. The new length, which is this L2, therefore will be equal to 1.74 minus 1.2. all right, so if you do that at the corner, 1.74 minus 1.2, so I'm going to have 0.54. yes, that's 0.54. that's going to be the value of this new length, 0.54. that will be the new length, but the original length we asked for is 1.74. I hope this is clear and very simple to comprehend. It's a very simple principle, but we could not take more questions because of time. All right.